All right, okay. So my name is Yun. I'm the CEO and co-founder of SolarLink. And today's topic is about advancing predictive maintenance and AI-based solutions for complex machineries. All right, that's me being a little bit silly. I have, as I said, gentlemen, before, I study a lot, I stay a lot in school, and then I work a little bit in manufacturing, learn about the real world, and in 2021, I decided to found the company SolarLink. So since then, I've been deep diving in the world of AI, IoT, and guess what? Predictive maintenance. So I don't know how many times I repeat these words every day, so that's why I live and breathe by every day. All right, okay, so by the way, there's a real picture. It's not AI simulated. This was last week, and I was part of this program. The program initialized by Morgan Stanley, program run by Morgan Stanley for startups. So they put me up, like my face was this big in front of the news. This was something. So based in Montreal, founded with me and my co-founder, two PhDs with a bunch of experience here and there. And we have the technology that's under development for the past 10 years. And only 4 years ago that we decided to make it a product. And our mission is to leverage AI and IoT to improve failure prediction, increase efficiency, and improve worker safety one machine at a time. Okay, so what is AI and why should I care, right? AI refers to a simulation of human intelligence that are programmed to reason and make decisions like a human. Or if you prefer, it's a computer program that runs and that try to do things close to a human. And it's a field that's been around for the past, I would say, 20 years. I took a course when I was in university back then. It's called AI as well. And what's different today is there has been a breakthrough in 2022 about generative AI. And this is where the biggest breakthrough in the past, I would say, 30 years in AI, including unparalleled capacity to generate text, image, video, and you name it. So I'm going to show you a little bit some of the images that we were able to, like by playing with AI a little bit, we were able to generate. So my husband took my pictures, played with this tool called Flux Prisora, and guess what? Those are not me, real me, right? So I don't have to work out or lose weight to look this good. So that's useful in a sense. And all the 3 pictures are generated, purely generated. Right, next one. So this was a few days ago. I went to ChatGPT and I asked the question, what is PMAC and what would be a good topic of a presentation here? This is what I did. And okay, so ChatGPT was actually able to go find the definition of PMAC. That's pretty good. I think it came from the website, and it even provided some citation. Excellent. And the 2 topics it proposed, the role of strategic asset management in enhancing organizational efficiency. The second one, leveraging CMMS for proactive maintenance. It's pretty good, isn't it? I would have attended these sessions given these topics, right? And I assure you, if you go on second, give me some point I can talk about for these topics. It's going to do a pretty good job. So it's kind of useful, right? In the industrial application, a few things I want to just mention. AI, for those who are not used to working with AI, what's different now is it can work with a large amount of data and unstructured data as well. So it doesn't matter where data comes from. Now we have framework in a cloud-based platform that's really accessible. So if you like playing with computer programs, it's something that you can go and create an instance and play with it. Those platforms help you to generate, to take in the data and do some data processes pretty well, easily. AI extends statistical analysis. So in the analysis world, there is math, just rule-based, base threshold, and that's on the left end. On the other end, completely, you have deep learning. You have large language models. So between the two, there's something called machine learning, MLs, and there's a wide spectrum between just statistical analysis and AI. I would say AI extends what used to be statistical and make it very efficient and useful. And third thing is what I think been enhanced recently with generative AI is enhanced decision making. So what it can do, it can input the textbook of what you want your team to learn, textbook about, let's say, vibration analysis, put it to the AI, and once it's injected this, 3,000 pages of text, you can start asking questions. So what happened is such and such happened. It's actually doing a very good job at understanding what you're trying to input to it and producing answers to your questions. So in that sense, AI is starting to behave very like the decision-making process that human used to do. You take data in, you try to kind of run through your head what I learned about this in the past and come up with the decisions. So it enhances the decision-making. It tried to imitate already, and at a very good, doing a good job. All right, next. All right, AI enhanced IoT. So IoT is what I know very well. And we're trying to bring AI to IoT. What does it help in the situation we have IoT system? Okay, it provides flexibility to complex machineries. So traditional IoT, they lack flexibilities. You basically have the sensors, for example, vibration sensors, and data brings in. You kind of just put a threshold, and that's it, right? That's your traditional IoT. You want to know exactly how much vibration is. The problem is in the real-time situation, like in a real factory, sometimes this winter comes in, temperature drops, temperatures go up, vibration changes. You don't have the time to always adjust the threshold just by hand, right? And what AI can do is it helps with flexibility. It adds you this flexibility of adaptive learning in the, say, a basic system of IoT threshold detection. And it can deal well with multi-sensor situations. Let's say you have a vibration sensor in one end, temperature sensor on the other end, and middle you have some other, ultrasound or oil analysis. The AI framework can work with multiple data at the same time. It is something that's inherent to how AI is. And of course, intelligent data interpretation. Basically, you can ask AI, well, I have a frequency, they come up with like 2 times RPM and temperature going up. What do you think is a problem? It's going to give you a pretty good answer, I bet you. So that's what AI brings us to our system. Of course, it has limitations, like anything. It is as good as the quality of your data. If your data is inconsistent, if it's lacking not so much, because AI can simulate data. But if it's not recorded in a consistent manner, let's say somebody moved the sensor. Let's say somebody put a sensor to, somebody changed the machine such the sensor where it should be, where it used to be, is not sensing the right thing anymore. It is as good as the basic of your data. Second thing, data needs to be labeled. Right, this is something that nobody has realized until now, is that even though you're dealing with unsupervised learning, you need to know how good your model works. How do you know how good your model works? You have to track the performance index. How do you track the performance index? You have to know what the model is supposed to produce to start with. Otherwise, you don't know what you're doing, you're just crunching numbers. It could be garbage in, garbage out. You wouldn't know. So data needs to be labeled at this point. You can disagree, but we'll have a debate afterwards. And otherwise, AI cannot find what is not in the data. It could happen that, magically you just dump 300 gigabytes of data into AI in crunches after, 1 week, and magically you find something you didn't know exists before. Unlikely. It's going to find what you can have in the data. So if you're sensing temperature in a factory, you're not going to know much about what's happening outside the factory. So unlikely to find something that's not in the data. Last one is the last one. The model needs to be maintained. So they drift, they don't work all the time. In fact, the models are like your machines. If you don't take care of it, it may not work anymore, and you have to provision time for it to work as you want it to work in a regular basis. Finally, AI is not a silver bullet for all your maintenance problems. So that's a picture of me again, my husband playing with the AI, and I love my company, but I assure you I don't have a calculator in front of me, or the name of my company. But anyway, AI is not a silver bullet for all your maintenance problems. If you don't take the time to plan, if you don't have people accountable for what they're not supposed to do, it's not going to help you. All right. Our journey with predictive maintenance. So me and my co-founder, we kind of, over the years, saw there was an improvement in the wireless protocols. 5G, Bluetooth has become more and more reliable and more easy to use. Second one, microprocessors, right? Right now, with same amount of energy of joules, you can produce a lot more outcome. The processing has become cheap in money and in energy consumption. So we told ourselves, how hard could it be? You just put, wireless sensor everywhere and start sensing things. That would be our, what I think happens, right? You have that perfectly stable vibration over the hours, the days, and you don't even need AI. You just need threshold. That's it. You can detect if it's wrong, good or not. And then we encounter this kind of signal. It's starting to get a bit more difficult. Like, where would you put a threshold? How about the spikes? Are they good or not? It's getting hard. And then you have this kind of thing. And that looks different in the winter and in summer. So this is actually a cooling tower. The final cooling tower runs differently depending on how the need of a factory. So good sensors are not enough, right? You need something more than that. We run into challenges with variable speed, drive that drive the machine differently. So you cannot just say that the first vibration thing is going to be what you encounter all the time. You have some machines that are overloaded. So I work a lot with food manufacturers, and they tend to have different recipes throughout the day. A bread factory we work with, they say they have 200 recipes in one day. So are you making whole wheat bread or hamburger bun? The vibrations are going to be different. The load on the machines are different. So we came to a conclusion, we need something more. We need something more intelligent than just thresholds. So I'm going to show 4 use cases of what we have successfully been able to detect as failures. Hopefully, it gives you an idea how we use AI to monitor the machines of our customers. So the first one is boiler fan. This is in a dairy factory. So that's actually the graph of a bearing stuck. So in this particular case, just giving a threshold is not enough because there are spikes that happens less frequently before it's bad and more frequently when it's good. So one thing you can do is you can kind of calculate an energy that you can detect that's being coming out of this bearing. The more failure, the better it is, the less energy you can detect. So something you can do, and what we did was pattern recognition. Kind of just cut into pieces. Pattern recognition, we're able to predict the failure that gave our customer about a week to react. So these are the 3 things that we can measure with our sensors. We have the sound, acoustics, we have the vibration and 3 axis. What's interesting is the temperature. So what you see, the up and downs, that each cycle is every day. So every day the temperature kind of go up and down, but there's a rising trend up to where you see the problem is being the worst. So that's your temperature being too high caused by a stuck bearing. Use case number 2 is a kettle, drive, and a motor. So this is a hot sauce. The company make hot sauce. So they have this big boilers and the driver of the motor and the kettle drive. In this case, data from 2 different sensors are required to detect the failure. So what happened here is you have the kettle drive vibration and the motor vibration pretty much in a synchronized way. They happen almost at the same time. Sometimes in the area where you have arrows, that's when the product is not well mixed enough, so like kind of try to drive, it doesn't work. But overall, it's pretty okay. You have like this synchronous signal between the 2 sensors. And this is a case where there's a slippage between the drive and the motor. And you see it was, it was okay. It was kind of bad and went back to okay. And it's bad at the end, kind of just broke. So you could drive as much as you want. The motor was driving, but the drive was not reacting. So in this case as well, you cannot just detect with simple threshold and with your vibration sensors. Use case number 3, weather indicator. This is when we have our sensors up at the rooftop environment. And in this case, living in Canada, we are Montreal-based. Especially in the springtime, this huge temperature variation between each day, right? You have the cycles every day. So what we have is we have the temperature on our sensor, the measuring things up and down. Like, it's kind of difficult to know if the motor is doing something bad if you have the temperature varying so much, because this is outside. So what we did is we separate the 2. We subtract the signal of our motor from the environmental temperature around that period of time. And then the graph on the bottom is what you get as residual temperature of the motor. It still has some up and downs because it is, I guess it's the production cycle, but as you can see, it doesn't move that much as compared to what we originally sensed. Another example of tracking the environmental temperature makes sense. So in this case, you have temperature of the sensor and ambient temperature. That's the red. Can I do? All right. Okay. So that is our ambient temperature right there. So what we did is we have these vibrations. Try to correlate this with that, and what happened? So that particular case brought up to here is that instead of taking a temperature we measure on the sensor, we have the residual temperature after we remove the environment temperature. And as you can see, this is actually an anomaly. You see right there, the vibration is less. Sometimes it's not necessarily good. The sound kind of, the residual temperature really went up. So this is another case where you cannot just rely on one sensor. You have to also look at the environment variables. Case number 4, compressors and pumps. All right, so one day we received a notification that something's wrong. So we look at the data, temperature dropped from 20 degrees to 4 degrees. Vibration pattern completely different. But it didn't go out of our basic threshold detection. So what happened was that it was a customer told me afterwards. The check valve broke, so coolant was flowing inside the head of the compressor. In this case, we're able to save the repair cost. That's pretty much the cost of the compressor. If they find out too late, you have to repair the compressor. Another thing I want to point out is here. So what happened here is they install a variable drive to a compressor. And this is an example of you cannot just have a model and have it run and not take care of it anymore. After this, we actually have to go back and retrain the model because the vibration pattern is completely different. And any change you make on your machinery, you have to be careful that the baseline you used to rely on is going to change. And if you want to get good result, you have to go back and train the models. All right, water pump in dairy facility. So in this case as well, when the temperature rises, the pump has some problem of maintaining the pressure, so we have these spikes here, and also you can show it in the sound data. In this case, I would say, yeah, maybe you could be detect with basic threshold, but also we're able to detect this with pattern recognition as well. This is something we didn't see before. We're trying to keep up, but weren't able to keep up. All right, finally, the solution that worked. We have a smart sensor built by ourselves, engineer. I think we have the best sensor in the world. Purely subjective observation. We have the vibration and the 3-axis, temperature, acoustics. We also found that simple spectrum done by our sensor in a regular basis, it really helps because only having the amplitude of the variation is not enough. You have to know more about how the amplitude is about. So you have to kind of know the frequency spectrum. And we also learned that it's difficult to interface with factory Wi-Fi for good reasons. That's why we come up with our own LTE. We go don't worry about the connectivity, we'll do it for you, completely taken care of and protect it ourselves. So your corporate Wi-Fi could be very good or very bad. It doesn't affect us. This happened in the past but also in some cases, there's no LTE, so we need to work with Wi-Fi. Those are exceptions in the norm. And we learned that without adaptive analysis, multivariable analysis, we would not be able to deal with the kind of signal that we encountered, especially in the food and beverage sector. And that we make the sensing frequency configurable. So in some cases, the machine moves really fast. For example, linear motors, we want to capture every point of when the motor moves. So the upload frequency could be as low as 2 seconds. And in some other cases where the machine is almost always constant, and in this case, you can put it once a week, no, not once a week, once an hour or once a day, something like that. So the solution we found that work with even the most difficult cases. How we learn? It's hard. It's not as easy as we think. It's not like asking your ChatGPT what would be a good topic to present in a PMAC conference. It's not easy because the tools are very flexible. You have millions of models you can take. Which one is good? Maybe there are many that are good. How would you know it's good, right? It's hard. Second, traditional IoT produce too much data. So basically, we can just tell a customer, oh, we install IoT, you just look at the data yourself, right? Most of our customers, they don't care about data. They just want to know if the machine is to be repaired. So just giving them the data is not enough. We have to provide the service of making sense of the data so they would use it. Otherwise, they would just not use it, in which case everybody loses. We have this system that nobody uses, and it's kind of just waste of time and resources for everybody. AI is actually useful. So we use it every day. in our analysis. And the picture of Roombot. Anybody has Roombot in their house? Right. It doesn't replace somebody who cleans the house, right? It kind of just, you could clean the floor, not around corners. It doesn't do the full job, but it kind of does the bulk of the work that you want to avoid. So it's not so bad. It's kind of useful. And also you need to know what you're looking for. There are cases where you, like I said, magically you just throw data and in AI, after 3 weeks, it produces something magical. It doesn't happen very often in real life. You have to know exactly what you want to obtain, otherwise you'll be wasting a lot of time and resources. And guess what? You have to monitor the performance of your AI models. Things like F1 score, F0 score, like confusion matrices, you have to have that in a regular basis. Otherwise, you would not know if your AI still works. So one experience what we had is we had the model train very well in the wintertime. Took us about a week or so to put it in a production pipeline, data pipeline. And guess what? It's spring and it's summer. And what we used to think, the way it behaves is completely different. I have to go back and train it again. So if you want to put AI analysis in your analysis pipeline, you have to monitor the performance in a regular basis. Our challenges. Data labeling. So you may say, historian, we have like 10 years of data back then, but what do they mean? Is it good or is it bad? Like have all these data, like when is that supposed to be abnormal? What is your baseline? You can say, I remember 2021 between January and March, there was the best time. So go back and label the data. Label that as your baseline. And then afterwards, you match it. If you don't do this manually, you wouldn't be able to monitor the performance of your models first. In our case, I have to do it ourselves. Because guess what? The customer, they don't do it. So, for us to provide service, we have to do it ourselves. Second thing is customer feedback, a lot follow-up. So the challenge we have is, let's say I alert the customer something's wrong. They do something, and we see things being changed, but they don't tell us. What happened? Went back to normal. Oh, we changed the motor. Like, could you at least tell me so that I can put it so that it is incorporated into my data labeling? Or it could be that things went back to normal, but they didn't do anything. So maybe it was just false alert. In that sense, I need to know as well. And also, because the more the customer tells me, the more precise my model would be. So that's it for my presentation. Do I have some time for questions?
Yes. So we still have like 15 minutes for questions, comments. Thank you.
Hey, thanks for the presentation. The example that you gave with using the, I guess, weather temperature, did you consider comparing against another temperature probe inside the building?
It could, yeah. It's something we could have done. But each room in the building is different, has different temperature as well. Some are hotter because of temperature around, and some other places is cooler. We just thought the environmental temperature provided by Environment Canada would be a good starting point. Yeah, but your comment is valid, of course.
How do we start in using AI in our processes? What's the process to do this?
I would say start with trying to define your problem and know what you want to obtain as a result. Then you work backwards. And then it could be that what you're trying to get is impossible. So you know right away. You don't just hire a bunch of engineers and data science, sorry, I'm an engineer myself, and they'll just work hard, a lot of typing, programming for 5 years, but you don't get anything if you don't measure what you want to obtain in the first place. Yes?
What are the benefits of this versus traditional vibration analysis? Because it seems like you need someone to analyze the data regardless of AI or not.
AI is just a tool. And in fact, it's not a tool, it's a bunch of tools that you could use. It is kind of different than the traditional analysis because then you have like rule-based analysis. There's something you can do if you know exactly what you're looking for. For example, if you're only dealing with pumps and only you care about pumps, yes, rules, if else, a bunch of them. But if you try to use the same solution for pumps, compressors, fans, then you probably have to develop different set of rules. But at the end, maybe it's easier to have something that adapts. It depends on the case.
Okay.
Follow up?
Actually, different question.
Okay.
With your challenges of data labeling and customer feedback, do you see potential for applying LLMs to things like the EAM and shift reports and other sort of non-time series data sources to try to supplement that customer feedback and other things?
That would be a great solution to what I'm facing, and we haven't tried. So this is something we could have done, yes.
We are doing that in Calgary, looking at the work orders,
Okay.
looking at language learning, machine language learning to supplement the PM data coming back to read the notes, the tech notes. So the machine learning is reading the tech notes and deriving more information to supplement the drop-down menus that we had in the work orders.
So excellent. Just we haven't been able to do that because everything takes time and we're not there yet. Thank you.
Good presentation. I really appreciate it. I would just like to understand right now, you're generally going on 3 variables that you're applying. The ability to expand to more, so example, you have the pump, mean temperature, bearing temperature or pump temperature, but then there's product temperature, product pressures and things like that, that all add to the variability of the life cycle of the equipment. How difficult is that to expand this type of AI into that, or is there limitations right now that hold you back?
I would say that the hardest limitation is time and effort because every production line is different. So you pretty much have to build a set of models for each production line, unless you have really identical production lines. And I would dare to say that every factory is very different. And it just takes time to do it right. And I think the benefits of it is kind of adaptive and self-learning if you do it right. It could make it so rigid that it's not better than before. But the tools is there, the framework is there so that you can make it adaptive to its past performance. And that's super key. You have to measure the performance, otherwise you cannot improve. I think that's true for any aspect of our life, right? So nothing stops us from that. One thing is very important is timestamping. So production line continues, right? And these sensors, they have to have the proper timestamp, so you know exactly what this moment equal to this other moment our sensors have to synchronize. That's the technical challenge I see that I can think of right now. Of course, there are others, but I can't think as well in front of audience than by myself, so there you go. Questions?
Any more questions, comments? Okay.
So the question is, in your slide, you mentioned about AI will not give the data not in the data set. Actually, I'm hoping we do the trial, such as Mario said. We do another experiment for the goldfish in the ocean. I can give you the one example. For example, when we analyze the work orders, we found file stations always have some similar problem, but it's not always in the same station, it's rotate. And of course, we have the no clue. When AI doing the analyze and they found the requester is always from the same firefighter. So basically, that the firefighters, when they locate the fire station, he always complains the same questions. So that is we never thought. You know, so I don't know, such as when you mentioned about the compressor, all this, it's kind of they pick up the abnormals, or they give to that the solution. Or you just kind of say pick out the abnormals, then give back that abnormals to the engineer, reliability engineer, to analyze what is that the solution is.
So we're not there yet because we're kind of new in this. But what could happen is you have anomalies. And then you go and you see what are anomalies. Temperature rising, vibration going down, and you take this information, you go to a large language model, okay. Let's say you have a compressor that does this and that, and under these conditions, what do you think are the possible cause? And it's going to give you a few answers that's probably in the right direction. So yeah, this is the follow-up connection you can connect to once you detect anomalies. But anomaly detection is your first steps. Otherwise, you just have too much to ask ChatGPT. Well, temperature study, vibration study, what do you think? Things are okay. So it's kind of like you divide the problem into different phases, but yes, you could eventually connect the output of your anomaly detection and connect it to a language model that could give you a potential cause of your problems. Absolutely, yeah. Hard questions, James?
Okay. Sorry, James.
Great presentation, by the way, but question about operating parameters. One thing I've noticed with machine operation is it's often impacted by the way the equipment is actually being operated. You can monitor the equipment condition directly, temperature, vibration, things like that, but you can almost use operational parameters to predict when it's going to go wrong. And I'm just wondering if there's a way of maybe correlating operational parameters with the machine monitoring data to kind of develop those correlations and actually help the operators operate better.
The answer is, of course. It's like what the gentleman asked before about including also the operation data to your machine vibration data and see if, dare I say, a certain operator always operates better than other operators, maybe. Or maybe it is the time of the day. Maybe at lunchtime, there's always a break because people want to put a break and go to lunch. We don't know. But the answer is yes, absolutely. Yeah. There's nothing stop us from doing it besides, it takes time and effort.
Any more questions or comments? Okay.
You mentioned from the sensor to the data transfer, like you use the LTE plus the Wi-Fi gateway, and you said it's stable data transfer. So do you guys provide a service for the hardware and the software, or just?
Okay, so shameless plug of my company. Yes, we do. We provide the sensor, the gateway, analysis, everything. Yeah, but we need your help to tell us what's really happening in the factories for me to get better. That's the part that we cannot do because you are in the factory, not me.
Okay, thank you, everyone. But please, if you go to your app, there's a link there for you to complete a survey. That survey helps us in further planning of subsequent, presentations and sessions in our next PMAC events. So I'd like us to give a thanks to Yoon, just to appreciate all the good work that she's done, she's put together. And please feel free to consult her later, after this presentation, and of course your lunch as well. Thank you.
Thank you so much.